Hi, welcome to your subject MECH 2, Dynamics of Rigid Bodies. Okay, so we will now be discussing. Okay, by the way, I am Engineer Angloan. Okay, I will be your instructor in this subject. Okay, so I will be introducing you what is dynamics as a branch of mechanics. Okay, so Unit 1, I will be introducing you the branches of your dynamics, mechanics, okay, where your dynamics is found. Okay, so in this unit, we will be, having these learning outcomes. Okay, so here are the following desired learning outcomes in your Unit 1. We are going to differentiate the different branches of mechanics and then identify the branches of dynamics. Okay, where, as I've said a while ago, dynamics is a branch of mechanics. We will see that one later on. And then relate particle and body. What is particle and what is body? Okay, so this is your engineering mechanics. Okay, so engineering mechanics may be defined as the science which considers the effect of forces on rigid bodies. Okay, the subject divides naturally into two parts, your statics and dynamics. Okay, so if you try to look here in your diagram, under your engineering mechanics, it is subdivided into two branches, your statics and our subject right now, which is your dynamics. Your statics, you already finished this one before, isn't it? That is your statics of rigid bodies, or your rigid bodies subject, MECH 1. Okay, so under that statics, okay, statics by the way is considered is the in statics we consider the effects and distribution of forces in rigid bodies which are and remain at rest or having of constant velocity. So that is what you did in your statics or statics of rigid bodies. Okay, you discuss what are the force systems, your concurrent forces, parallel forces, and non-concurrent forces. And then you apply that one in your thrust, centroids, and friction. So again, what is statics? Okay, statics is just the study of the application of force into a body that is considered at rest. Okay, or it could be a rigid body. By the way, is also could also be or statics could also be referring to a moving object, but the velocity is constant. So that is a what you call this one rigid, considered as rigid or statics. So again, if you will try to study the effect of force on an object at rest, that is statics. Okay, so that is statics. Now we will proceed to your second branch, which is actually our subject right now, your dynamics. Okay, dynamics of rigid bodies. So in dynamics, we consider the motion of rigid bodies caused by the force acting upon them. Okay, so in statics, we consider that even if there are forces applied on your object, there is no movement. That's why it is rigid. Okay, it is static. There is no movement. Now, in this dynamics, we will now be considering, okay, that your object, when we apply an outside force on that object, there will be a movement. There will be a motion. That's why we call it dynamics. Okay, there is a motion at the same time. So we will be studying the motion caused by the forces applied. Okay, so under that dynamics, okay, so we will now focus on this since that is our subject. Under that dynamics, it is subdivided into two branches, your kinematics and kinetics. So if we say kinematics, okay, that is dealing with translation, rotation, or plane motion. We will try to define this one later on the next slide. Okay, and then kinetics, that is referring to translation, rotation, and plane motion also. Okay, so we'll try to, okay, here I will define what is kinematics and what is kinetics. Okay, so if you say kinematics is the geometry of motion. Okay, so the term is used to define the motion of a particle or body without consideration of force causing the motion. So in kinematics, that is simple as studying the movement only without considering the cause of that, which is the force, or the effect of that, which could be a force. So it is plainly the movement. Okay, we are studying plainly the movement. Okay, So that is kinematics. Okay, kinematics is essentially a treatment of the relations between displacement, velocity, and acceleration. So you had this one in your physics, your displacement or distance, your velocity or speed, and the acceleration. If we are trying to study this one, that is your kinematics without considering the cost, which is actually there is a movement because of a force, isn't it? But we will first neglect that force, that we will just focus on the movement. That is kinematics. Okay, so how about the kinetics? Okay, kinetics is the branch of mechanics that relates the force acting on a body to its mass and acceleration. Okay, so that is now. Okay, your kinematics is plainly the movement. Your kinetics is now considering the force. Okay, so that is kinetics. We will consider the force that caused the movement, or the force that could be caused by the motion itself. Okay, so when the acceleration of the body caused by the force acting on it has been determined, the principles of kinematics may be applied to determine the displacement or velocity of at any instant. Okay, so again, the same, we will be studying the movement, but at the same time together with the cause, which is the force. Okay, in other cases, the kinematic motion of body may be used to compute its acceleration. From this, by means of the relation to be developed later, the force or force required to produce this motion can be determined. Okay, so that is kinematics and kinetics. Okay, those are the branches of our dynamics. So those are the soul of our subject, your dynamics of rigid bodies. Okay, how about this word particle and body? Okay, so since we are referring here to rigid body, okay, let's consider that. Okay, rigid body may be defined as a body in which the relative positions of any two particles does not change under the action of forces. Okay, so the relative position. So rigid body, rigid. Again, there is no movement. Okay, rigid body. Okay, so again, there is no this space, what do you call this one? There is the relative position of any two particles does not change under the action of forces. Okay, so that's it. The displacement. Okay, nobody is perfectly rigid, which is true. Yes, there is no, but there is nothing perfectly rigid if there is a force applied. Okay, maybe even if a very small, there will be an effect, very small force applied, there will always be effect, but maybe very small. That's why uh, we cannot, what do you call this one, cannot see that one. But still, there will always be a movement, or it could be a deformation. If we say deformation, let's say that's a box and you're going to press, there will be a sag, that is deformation. Okay, that is deformation. Or let's say displacement, if you will push, there will be a movement. Okay, so there will always be a movement. Okay, there will always be a movement, even if that's a very small. There is no such as perfect rigid. Okay, there is no such as perfect rigid body. Okay, it must be undergo some deformation, however small it may be. Okay, so that's it. But again, rigid, okay, even if that is moving, if we are referring that one to a reference point in the displacement, the displacement between them will not change, that is still considered as rigid body. Okay, okay, so that is your rigid body. Particle. How about a particle? Okay, that is a body of infinitely small volume. Example, okay, that is a very small body with a negligible volume. Okay, so that is the called particle. Okay, your again a body that is has a dimension of a negligible dimension, or a very small volume, that is what we call the particle. Okay, such a body cannot exist theoretically. Yes, it doesn't exist theoretically. Okay, in other words, a particle is a body so small that any difference in the motions of its parts can be neglected. Okay, so this is now the difference of body. Since body is a considerable size, if you will try to have there a, what do you call this one, motion, you can see even if that is very small. But if that is a particle, a very small, and the motion is a very small also, then it seems like the movement, there is no movement at all. So that could be neglected. But actually, we will try to understand that one. It depends on how that word particle is being used. Okay, if you are referring to a particle, in the whole body, let's say a whole body is divided into particles, then that is different explanation. Okay, so again, a body and a particle. Okay, so that is for your unit 1. So let's review the important concepts there. Okay, so first is that dynamics is the study of moving bodies. Okay, yes, that is dynamics, moving bodies. Kinematics defines the motion of a body without considering the force causing the motion. Okay, so it is just studying plainly the movement or the motion itself. Kinetics relates to the force acting on a body to its mass and acceleration. So again, a motion only alone is kinematics. A motion with a force is kinetics. Okay, simple as that. That is your introduction. That is our unit 1. Okay, so let's proceed. Unit 2, motion of a particle. Let's try to understand what is the motion of a particle. Again, particle, we are referring to a very, very small or negligible size body. Okay, so again, in this unit 2, this is our learning outcomes. We will try to define what is motion, identify the different types of motion. Okay, what is there a type? Okay, we will see that one. What are these types of motion? And then identify the different types of rectilinear motion. Okay, so we will understand that one as we go on with this unit 2 of our discussion. Okay, so motion. What is motion? Motion is one of the most common phenomena we came across in our daily lives. Okay, so that is just a common phenomena that we are encountering in our daily lives. For example, there is a movement of a car or a moving car. That is a motion. A kid running on the road. That is also a motion. Okay, or a plane flying in the sky. These are all motions. Okay, so in general terms, a body is said to be in motion if it changes its position. Okay, again, position. Position. So if you say position that is in reference to a fixed point. Okay. So if you can say that a body did not have a motion or there is no motion in that body if the distance from a reference fixed point, if you say fixed point, that will never be moved. Okay, that will always be fixed. So let's say this is your particle and this is the fixed point. And how do you know that there is no movement? Since the distance will always be the same. There is no change in the distance. But let's say even if there's a slight indentation, there is a motion. Okay, so as simple as that. Even if a very, very small movement, that is so-called motion. Okay, so that's it. So again, your motion. Okay, so in general terms, a body is said to be in motion if it changes position with respect to a reference point, or that is a reference fixed point at the end time. So again, this is actually time is always related to motion. Okay, time is always related to motion. So there will be a movement as time goes by. Simple as that. Okay, motion. Motion happens if there is a movement as time goes by. Okay, so that is motion. Okay, so here are the types of your motion. Okay, the motion of a particle along a straight line path is called rectilinear motion. Okay, so let's say the movement is straight, the flow of movement is straight. It doesn't matter if it is inclined, if it is going down, if it is going up, if it is flat. Again, as long as that is following a straight line, that is what we call as the rectilinear motion. Okay, the motion of a particle along a curved path is called curvilinear. So if the motion itself is in a curved path, that is curvilinear motion. Okay, we will be dealing with that one also. Actually, you already encountered this one. If this is discussed in your physics, that is your projectile. Okay. If a moving particle describes equal distances in equal periods of time, however small, the motion is called uniform. Okay, so how are we going to understand this one? Okay, so if a moving particle describes equal distance in equal period of time, let's say there is a movement. Okay, let's say there is a movement. Okay, let's say, okay, do not have my, okay, so let's say this is the particle. Okay, let me just get my props. Okay, so I have here my props. Okay, so let's say this is a road. Okay, So let's say there is a car. Okay, there is a car, toy car. Um, how do you know that that is a uniform motion? Again, let's say that is the origin. That is your origin. At time, it says there that equal periods of time. So let's say we are trying to investigate per minute. Okay, so let's say at 1 minute, that is the location now of your car. Let's say that is point A. And another 1 minute, that is the location of your car. That is your point B. You can say that the motion is uniform. Okay, the motion or the movement of the car is uniform if, since we are considering 1 minute each, isn't it? We are considering 1 minute, 1 minute each, 1 minute each. Okay, since we are considering 1 minute each, and let's say that the distances in this equal time interval, 1 minute each, is equal. Let's say this is distance, that distance is x, and that distance is also x. They are equal at the same time interval. Then it means that, okay, your motion, the movement of the car, or the motion of the car, is uniform. Okay, so that is how we can say that the movement or the motion is uniform. We call that one uniform motion. Okay, how about if unequal distances? Okay, if unequal distances, let's say 1 minute, the interval is still 1 minute, because that is how we will know if it is uniform or not. We will be considering equal interval. Okay, so in each 1 minute, let's say this is x and x, that will be uniform. But let's say that is difference. That is x, and this is a different distance. This is y. They have different distance in the same time interval. So that means this is, okay. It says there that uh, if unequal distances are described by the moving point in equal periods of time, the motion is said to be non-uniform or variable motion. Okay, so again, let's say that the car is going fast. Okay, going fast from at rest, it will now start to accelerate. It is now accelerating, so it means that the speed of this at this point is different at this point. Okay, the speed at this point. So what do you expect? Even if that is 1 minute and that's 1 minute, the car here is slower than the car there. So you will expect that the length here, or the distance traveled in this second minute, is longer than the first minute. So that is non-uniform motion, or we call that one the variable motion. Okay, or that is also the same. Let's say this is trying, this car here from point O, or the origin, is slowing down. So from a high speed, it is now slowing down. It is now braking. So again, the velocity here is faster, and the velocity there, or the speed here, is lower because of the braking. So what do you expect? Different distances, even if they are equal 1 minute. So that is non-uniform or variable motion. Okay, so those are the types. If the motion is straight, is following a straight path, that is rectilinear motion. If that is a curve, that is curvilinear motion. Actually, there is one more. If it is following a circular pattern or circular shape, let's say for example is the revolution of a windmill. Okay, let's say this is a windmill rotating, continuous rotating. It means that there is a movement. Okay, there is a movement following a circular path. We call that one a rotation or circular motion. Okay, we will be having that one also. Okay, so let's go to rectilinear. So what is rectilinear motion? When we require only one coordinate axis along with time to describe the motion of particles, it's said to be linear motion or rectilinear motion, or as simple as if the flow of the motion follows a straight path, that is rectilinear motion. Okay, so some examples of linear motion are a parade of soldiers. Okay, let's say a parade of soldiers following a straight path, train moving along a straight line, and many more. Okay, so these are examples of your rectilinear motion. Okay, so for example, is use of elevator in public places is an example of rectilinear motion. Let's say Of course, because elevator, the path of elevator is a straight line, isn't it? It's either going up, going down. That is rectilinear motion. Gravitational force acting on an object resulting in free fall is an example of rectilinear motion. So in this picture, okay, second picture, let's say an apple is falling down from the tree. Okay, an apple is falling down from the tree. That will follow, of course, the direction of your gravity, which is straight going down. So that is a straight line. That is also rectilinear motion. Kids sliding down from a slide is a rectilinear motion. Yes, it depends on what slide. But in this picture, that slide is a straight inclined slide. So of course, that is a rectilinear motion. But there are slides wherein it is a curve. So that is not a rectilinear motion. Okay, that is only for the example in this picture. Okay, so if that is following again a straight path, then that is a rectilinear. And so it is. So plane, motion of planes in the sky is a rectilinear motion. Yes, but depends, because maybe isn't it the pilot is changing direction? Is that possible? Yes. But again, since we are just focusing on the straight movement of a plane, then that is rectilinear. Okay. So those are just example of our motions. So these are the three types of your rectilinear. So again, rectilinear is a type of motion, and under that rectilinear there are three types. Okay. So first is your uniform rectilinear motion. Uniform rectilinear motion. Okay, when an object travels at a constant speed with zero acceleration, it is known as uniform rectilinear motion. That is my example a while ago. Let's say the movement from this point O along to your point A and B is the same. There is no acceleration. If you say acceleration, there is no variation in your speed. Okay, your velocity is constant or your speed is constant. Then it means that is a uniform rectilinear motion or uniform motion. Okay, the rectilinear because, okay, uniform rectilinear, the word rectilinear again because we are following straight path. Okay, so acceleration is zero, that is uniform rectilinear motion. Uniformly accelerated rectilinear motion. Okay, so that is variable motion. Okay, it means that this is xy, but the term there is that uniformly accelerated. It means that the acceleration, it means that the acceleration as it passes or as it passes these points, or the motion itself, the acceleration within the motion is constant. So let's say you are driving a car. Okay, you press the accelerator at a constant angle. So that is constant acceleration. Okay. Okay, so that is constant acceleration. The acceleration all throughout the motion is constant. We have here also the third that will happen if, okay, your acceleration is varying. Okay, rectilinear movement with non-uniform acceleration. That is the our term for that. Again, a while ago, if the acceleration is zero, so it means the movement is uniform. That is uniform rectilinear motion. There is a second one wherein there is an acceleration, but that is constant acceleration. That is uniformly accelerated rectilinear motion. And how about if the acceleration is varying? It depends. Okay, which is actually the actual scenario if you are driving a car. Okay, you can have a varying acceleration. So that is what we call as the rectilinear movement with non-uniform acceleration. Okay, so that's it. The three types of your rectilinear motion. So these are the important concepts in your motion, your unit 2. Rectilinear motion can be classified according to its interpretation of acceleration. Yes, it depends on the acceleration. Rectilinear motion requires a one coordinate axis. Okay, if you say one coordinate, that is just a straight path. It doesn't matter if it's inclined, going that way, this way, or that way. It doesn't matter as long as that is a one axis. Okay, one coordinate axis, or that is just a straight line. Rectilinear motion is also linear motion, or that is just another term for rectilinear. Okay, because again, that is just following a straight line. Okay, so that is your unit 2. How about your unit 3? Okay, in unit 3, we will be discussing here your position, velocity, and acceleration. Okay, so our unit learning outcome here is first to differentiate what is distance and what is displacement. Second is to differentiate speed and velocity. Third is to define mathematically velocity and your acceleration. So we will try to, if we say define mathematically, let's try to understand the mathematical relationships. Okay, so position. If we say position, okay. So now that we have learned about the linear motion, we will discuss two terms related to your change in position. So again, if we say position again, that is the relationship of a particle, if we are referring to a particle or a body, from a reference point or a fixed point. So first there is the distance. You will have these two terms, your distance and displacement. So let's try to differentiate these two terms. So if you say distance, that is the total path length covered during a journey. So that is just the length of the journey or the motion. Displacement, okay, in displacement, that is the path length from final position of the particle to the origin. So how will we differentiate this one? Okay, let's try to have this one. Okay, example. You have here point O and you have here point A and point B. Okay, so we have an origin O. Okay, measurements to the right of O are taken as positive, while to the left are taken as negative. So we will be following sign conventions, going to the right and going to the left. Okay, so right is positive, left is negative. So just like in your number scale, so just like in your x and y axis. Okay, so you can also say that going up is positive, going down is negative. So we will be following a sign convention. Okay, suppose a person who starts from origin O, so again that is our point of origin, our point O, reaches point A. So it means that a person will be traveling from point O, which is its origin, to point A. So if you say distance, that is your line OA. Okay, so whatever the length of that line OA, that is your distance. And the displacement is the same. OA. Why? Because in displacement, that is positive. Okay, because we are following sign convention in displacement. It is going to the right, so it is positive. So they are equal. But let's say now he turns and reaches point B. So it travels from point O going to A, and suddenly it will go back to point B. So what is the distance? Okay, so this is now where the distance and displacement will be different. Distance is again the length, total length of the journey. So what is the total length? That is the line OA plus line AB. Okay, you will add all of that. That is all the length traveled by the person. That is distance. But displacement, okay, how about displacement? That we are following sign convention. So again, it says there, if we will try to go back, that is the path length from the final position from the origin, from the final position of the particle to the origin. So that is the distance of the final destination or final position to the origin position. So if you'll try to look here, what is the origin position if it traveled from O to B? The origin is point O. The final position is point B. So what is the length there? That is your displacement, which is line BO or line OB. However, again, in displacement, we are following sign convention. So we started from point O, that is our origin. And the final position is point B. So the distance from O to B is going to the left. So that is negative. Okay? So that is now when we will be having this distance and displacement different. Okay? So again, distance is just a distance, just the length itself. There is no positive, negative. Displacement, there is a positive, negative. It depends on the directions. Okay? And not every time distance is equal to displacement. Okay? So that is the explanation of your position. So velocity, we have here your velocity. These terms are used to describe rate of change of position. Okay, if you say rate of change, that is how fast the position is changing. Okay, by the way, okay, we can relate that one later on to calculus because that is one topic of calculus. Okay, so speed. Okay, speed is the rate of change of distance, while velocity is the rate of change of displacement. Okay, so again, in speed, we are referring to the quantity itself only. There is no effect of the direction, whatever that is. While velocity that we are using here, your displacement. So there is the effect of directions. So that is velocity. So again, the others actually just define these two words as speed is just a quantity, velocity. Okay, if you have your synonyms on, speed is just a scalar. If you say scalar, that is just a number, while velocity is a vector. If you say vector, a scalar plus direction, or a number plus a direction. That is the simple definition for speed and velocity. Speed, again, just a number. Velocity is a speed with direction. Okay. Okay, in mathematical terms, these are your definition as follows. Okay, so speed is just distance over time. Whatever the distance traveled during the time taken. So that is your speed. Velocity is the final position minus initial position. Okay, so again, final position minus initial position. If you will try to go back here again, that is your displacement, isn't it? Final position minus initial position divided by the time taken. So again, velocity depends on which one is longer, your final or position, or negative, or your initial position. So you will end up here with either a positive or negative. That's why velocity, there is a direction. If you are following a sign convention of to the right positive, to the left negative, then your velocity is a speed with positive or negative signs. Okay, so that is speed and velocity. Okay, so here is your velocity. This is the mathematical definition of your velocity. Okay. The linear velocity of a moving particle is the time rate at which the particle is changing position, or more briefly, the time rate of linear displacement. Okay, hence velocity, like displacement, possesses both magnitude and direction. Okay, the magnitude of the velocity of a point is called the speed. That is what I'm saying. Although the terms velocity and speed are frequently used interchangeably, because again, since they are the same, only that the other one is there is the direction. It is important to associate with the word velocity the two properties which it possesses. For a change in the direction or a velocity is fully important in the laws of motion, physical bodies, as a change in the speed. Okay, so that is very long definition, but if you will try to look here again, this is your equation. That is what we discussed a while ago. So if you will try to relate this one later on in your physics, that is your formula in velocity is change in s. What is s? Let's say that s is, okay, so let's say that s is distance. Okay, so change in distance. Final distance minus initial distance, whatever the sign that is there, divided by the time taken. Okay, so change delta, again, that the triangle is red delta, that means change in distance, change in time, or that is just the time taken. That is your velocity. But in calculus, that is the same, even if we are considering a very big change or a very small change. That is in your calculus, isn't it? That is in your differential calculus. So if you will try to apply the limit, if you say limit again, you understand that is a topic on your calculus. We will try to approach, that is the meaning of that. Okay, limit as delta t approaches, so that should not be equal, that should be approaches. So that means that if we will consider the change in time as a very small number, okay, very small number, let's say just a snap, the time we're just considering a time which could be considered just a snap of time, okay, then there will still be a change in distance, because again there is a motion. So even if you are considering a very long time, or a very short time, or you can just say a snap of a time, then that will still be velocity. So if you will relate this one again in differential calculus, okay, limiting your change in time as that approaches, if you say approaches, it goes near zero or very very small number, then that is actually your ds over dt, or that is the derivative of s with respect to t. That is your from your calculus. Okay, so again, this is what we will be using. Velocity is the again ds dt. Why did we use ds dt in calculus? Because not the triangle delta. Because again, that d there, that means we are considering a very very small. Your delta, your triangle means a big change. But since if we are considering a very very small change, that could be your d, which is your derivative. Okay, so that is your derivative of the distance with respect to time. How about acceleration? Okay, if you'll try to read that one, that will be a very very long, but that is the same as your the concept of your velocity. Velocity is the change of distance with respect to the change of time or time taken. That is the same as acceleration. Okay, the velocity, we are, instead of distance, we are now referring to velocity. So the change in velocity or final velocity minus initial, that is your change in velocity by the change of time, or that is the time taken along the motion. So again, delta v for velocity and then delta t for change in time. But again, applying your differential calculus, we will try to limit the change of time. We will just consider a snap of time, very very small. So we will be having a very very small change in velocity, but that will always be an acceleration. So a while ago, your velocity is derivative of distance with respect to time. Your acceleration is now derivative of velocity with respect to time. Okay, so those are position, velocity, and acceleration. Okay, so again, this is now the important concept in your unit 3. Distance is a quantity, is a scalar quantity. Again, that is just a number. Meanwhile, displacement is a vector quantity. Again, there is a direction. Distance can never be negative, but displacement can be. Yes, because again, there is a sign convention for displacement. Distance is just a number. Velocity and acceleration are both vector quantities. Yes, why? Because velocity is using your displacement, isn't it? That is displacement. We are considering here direction. Displacement, yun. Final position to the original position. So that is your displacement. So if velocity is using displacement, therefore there is a direction, therefore velocity is a vector. There is a direction. But at the same time, your acceleration is using a velocity which is a vector, therefore acceleration is also a vector. If you say again vector, there is a direction. Okay, so that is your unit 3. Okay, so let's continue to your unit 4, fundamental equation of kinetics. Okay, this is now the by the way, a while ago, those are your kinematics. We are referring to the movement itself. There is no force. Okay, we did not yet consider the force in your acceleration, velocity, and position. Those are your kinematics. So in here, we will now be understanding the fundamental equation of kinetics. Okay, so this is your unit learning outcome for this unit. Okay, to differentiate what is mass and inertia, and then understand or relate force, mass, and acceleration. What are these? Okay, so now again, if you'll try to look here, force will be related to mass and acceleration. So that is kinetics, isn't it? So that's why in here, we are trying to find or understand the fundamental equation of kinetics. Okay, so first, let's try to define what are these terms: force, inertia, and mass. Okay, for force, I think this is already discussed in your physics, but let's try again to define. Okay, force is a push or pull exerted on a particle. Let's say this is a particle, you're going to push that one. That quantity is called force. Okay, force. If we say pull, this because there are two directions. It's either you are pushing or you are pulling the particle. So that is still force. Okay, exerted on the particle. The only part of a force system that will cause the motion of body is unbalanced force. Okay, so again, you discuss that one in your rigid body. Let's say you will apply a force on a certain particle or a body. If that is not counteracted, to be balanced, then there will be a resultant. It means if there's a resultant, okay, it depends. If you say resultant again, that is the net force. Okay, let's say you're going to push this particle and there is, let's say, a slight cancellation of out another force on the other side. Then if this is stronger than that, then there will be a resultant. Okay, there will still be the resulting or net force that will cause the motion. So again, that is force, isn't it? So as long as there is an unbalanced force, or we call that one the resultant, there is an unbalanced force or resultant, there will always be a motion. Okay. Inertia, if you say inertia, that is the property of a particle to offer resistance to a change in motion. Although all particles have inertia, they do not offer the same amount of or degree of resistance. So again, there's a resistance from the body itself. That is what we call the inertia. Okay, and by the way, how is that? The common term for that is your mass. Okay, actually inertia is mass, but that is in quantity itself. Quantity measure. In a number measure, that is mass. But as an idea, mass is inertia. Okay, or as a concept, your inertia is the concept, the value is your mass. Okay. So let's try to let's try to relate these three. Okay. So consider this experiment. Okay, so consider this experiment. Okay, it says there apply an external force of different magnitude on the same body. Okay, let's say again you have this as your body. Apply different magnitude or different measurement of forces. Let's say force A, force B, force C. But of course, because you apply the different forces, the acceleration, okay, it says there, each cause corresponding acceleration. The acceleration, since the forces applied are different, the acceleration are also different. Okay, so if you try to divide here the force applied to the acceleration of the motion. So if you try to divide that, so this is your equation here. Divide the force by the acceleration, or that is just the ratio of the force over the acceleration. That ratio will always be equal, okay, to a constant value. So it means even if you put there force A and it ended up with acceleration A, and you will apply another force B and ended up with a different acceleration A, and so on and so forth. But if you try to get the ratio of the force over acceleration, that will be always be constant. Okay, so that is according to the experiment. So let's try to consider that C, or that constant, as constant C. Okay, that is the measure of resistance. According to this, that is the measure of resistance of the particle to be accelerated at a rate A after being acted by a force F. So that ratio, F over A, the force divided by the acceleration, is the resistance. That is your inertia. Okay? So, okay, that resistance, that constant C resistance is actually, okay, that C there is actually equal to a mass. That is proportional. If we say proportional, as mass, as that constant C increases, the mass increases. Okay, so that is proportionality. So if they are proportional, before you will put their equal sign, there should be a constant of proportionality K, isn't it? So again, constant of proportionality K. But since, okay, if you will try to input there, F over A is equal to C, since that is constant, or you can just change that one to your proportionality constant K and your M, because again, it is explained here. Then the unit force and the acceleration should be selected such that K would be taken unity. So if you will try to make your units for force and acceleration coinciding with each other, okay, again, force could be kilonewton if you say, or Newton, if you say Newton, that is, how is that again? Newton is mass acceleration. So per second square, that is a kilogram per kilogram per second square, isn't it? So that kilogram meter per second square. If you will use the acceleration, that should also be meter per second squared. So they will coincide so that your k here, your constant of proportionality k, will be unity. So if you will do that, then you will be having here your simple relationship of kinetics. Okay, this is now the simple relationship of our kinetics, wherein force over acceleration is your inertia, or that is actually your mass. That is your resistance. Okay, so force all over A is equal to resistance. Okay, so that is how we ended up with F over A. So again, the important concept in your unit force, that inertia is a body's property to resist motion when acted upon by external force. Okay, mass is the quantitative measure of inertia. So, okay, so that is the how we will measure your inertia, because again, inertia is the concept. The mass is how we will measure that one. So that is your quantitative measure, or that is your measurement. Okay, so if there's any question in this discussion on this recorded video, please just comment that below. If I can answer that one right away by comment, then that's good. But if not, then I will be answering your question, that question, on our live or synchronous discussion. Okay, so if you have question, just comment right away, or you may ask that one in our next live discussion. Okay, so okay, just the credits for the, this is the credits, of course, since this slide, actually we downloaded this one, a free template by Slides Carnival, and the pictures used is coming from your Pixabay, a free site for pictures. Okay, so again, thank you very much for watching.